You might find this a bit entertaining, but the glyph lights of my nothing phone is reflecting off the board here. Anyways, so I'm working on something here. It's not necessarily proprietary or anything. It's just some drawings of my healthy obsession with fractal curves that are non-overlapping. But right now, I'm going to make this sort of complementary fractal curve interact with itself so that we have specific points where it does overlap. And I marked the first 4 overlapping points that will happen here. You can see this very basic Fibonacci curve that goes around in this pattern. And I call this closed packed because I placed dots in the middle so that you could zigzag across. Instead of jumping directly from here to here, you could jump to here and elsewhere. And we say it's closed packed because normally, like for example, if there was maybe 3 or 4 atoms, then we can consider them little cellular structures that just are stacked directly on top of each other. But for something that is closed packed, you could actually place, say, an atom here in between sort of this curve like that, if that makes sense. And then you could put another one here and another one here, and you could keep going and then place them as close together as you possibly can all the way. And then if you're not careful, it ends up becoming on some kind of amorphous structure. But anyways, I've gone a little too far with that, trying to make that point. But this fractal curve, if it makes any sense, should be able to represent 2 arrows of this pixelated omega symbol. So you got 2 arrows going this way. You got right here, it looks like an arrow tip right here and here. And then you could draw something else on top of that where the arrow goes inwards 3 times. And if you put that together, you end up with these 2 arrows going out this way and the 3 arrows in between. And so then you would end up with a Fibonacci fractal curve that is complementary to some extent. This is half of it right here. And if I complete this drawing, let's see what it looks like. So we're going to go across somewhere this way, and it's actually supposed to meet right here. I'm not drawing it very nicely. There you go. Then it should be able to jump across this way and then go this way. And then there actually should be another point up here that this curve could jump to. Okay, it looks like I'm missing a little bit. Okay. And then it's supposed to cross over with that tip there. Okay. And then come up this way. There we go. And then come back this way. And then jump down to this point here. And I meet this section. Look at this. We've made this, looks like an angled letter T. And this is actually the arrow tip here. And now we're going to create another arrow tip here. It's going to jump right across this way, and it's going to stop right there. And now we're going to jump inwards and have this jump to this middle point that's supposed to exist here. Let's try that. Here we go. Jump right across. And then there would be another point up here at 90 degrees that I could reach. Okay? And then jump across down here and overlap with this point. Let me see. I may have gone too far. Okay, so the point that's up here is a little too far up. It actually should have been a little bit closer. And in that case, so that we could allow this point to come here, overlap here, and then keep going. Okay, and then come down here. There would be another dot here, so let's connect that. Come back across, jump down, and then overlap with this point here, jump down, boom. So now we actually have an arrow tip here, an arrow tip here, and an arrow tip here. So we got 3 arrows pointing inwards, and then we got these 2 arrows pointing outwards from the black one. So this, instead of coloring it blue, I should just color it black. Let me try that. This is all very abstract, so it's probably not going to make sense, but I thought you might find it interesting because drawing these things it starts to make some sort of sense after a while. I don't know if there's any any math you could map to this. I'm not a theorist myself, but I do find a lot of fascination in drawings, design. But the thing is, because there are points that can overlap by having 2 different self-avoiding fractal curves. So let me just draw it up here. It would be called a self-avoiding fractal curve. Fractal curve. Here we go. So that's what this is, really. And what we've done is, or we, by we I mean me, what I've done is taken 2 self-avoiding fractal curves that have this, that are easily represented by these arrow structures or arrow symbols that we can equate to this pixelated omega. I'm just going to call it that. We can actually create these specific overlapping points. And these specific overlapping points happen to be right here and right here. I guess you could say one overlaps here as well. Another one here, another one here, 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 right here, here, and here. So this is as basic as I could make it. I know there are some people that are kind of colorblind out there, but I'm going to use red. So we got one here, another one right there, and then we got another one here. I just hope that you could at least see the arrow. I don't think it's necessary. The color is not as important, but I'm just, for my own reference, because I can see red, I'm going to draw this here where the overlapping points are located. Look at this. And the thing is, I'm able to create the black dots here with a Python script. And right now I'm trying to figure out how to draw a Python script that can describe this blue line that is overlaid on top of that one. So we'll see how far we get on that. But I do find the fact that these overlapping points exist on here. The thing is, I'm gonna end up making some documentation on this in SVG format. Make it look really nice rather than just having a hand drawing or a picture. But anyways, take care out there.